Hello guys, welcome back to my YouTube channel. Today I am going to solve day 30 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today we are going to solve problem number 992, subarrays with k different integers. Okay, so this week we are getting same problems related to sliding window technique. So if you guys see my last 3-4 videos of this week, so you will find a similar type of problems related to sliding window technique. Okay, and today also we have got the same problem related to sliding window technique only, but this problem is marked as hard. Okay, but don't worry, by the end of this video you guys will find this problem very easy. Okay, so now let's read the problem statement first. So in this problem we have given an integer array nums and an integer value k. Okay, and we have to return the good subarrays of nums. Okay, and a good array is an array where the number of different integers in that array is exactly k. Okay, so let's understand this problem statement with one example here. So this is a nums array given to us, right? And k value is 2. Okay, so we have to form the subarrays in which there are total 2 different integers. Okay, so let's find out. So let's start from this first position. Okay, so 1 2 is a good subarray, right? Because here in this subarray there are total 2 different integers, right? So 1 2 is a good subarray. Then this 1 2 1 is a good subarray, right? 1 2 1 is also good subarray because in this also we have different integers, right? 1 to 1. Then 1 2 1 2 is also a good subarray because in this we have 2 different integers, 1 2 1 2, and 1 2 1 2 3 is not a good subarray because in this 1 2 3 total 3 different integers. Okay, then let's get started from this position. 2 1 is a good subarray. Yes, 2 1 is a good subarray because total 2 different integers. 2 1 2 is a good subarray. Yes, 2 1 2 is a good subarray because total 2 different integers. 2 1 2 3 is a good subarray. No, because there are total 3 different integers. Okay, so this is done. Now let's get started from this position. 1 2 is a good subarray. Yes, 1 2 is a good subarray. Okay, so here see 1 2 are coming 2 times. Okay, so we can include it 2 times. So 1 2 is a good subarray, right? 1 2 3 is a good subarray. No, so we don't need to include that. Now let's get started from this position. 2 3 is a good subarray. Yes, 2 3 is a good subarray because in this subarray total 2 different integers. So in this way we have found all the good subarrays, right? And then after that we are going to do the count. So 1 2 3 4 5 6 7. So 7 is going to be my output. Okay, so I hope that you guys are clear with this problem statement. Now let's understand this problem. Okay, so initially this is a brute force people will use. So what they are going to do, they are going to take one array 1 2 1 2 3. Okay, this is a brute force, but we are not going to apply this because this is going to give us we are going to solve O of n square. Okay, we are going to solve this problem in O of n square. Okay, using this brute force type method. Okay, so in this what we did, we take both left and right starting at this position. Then after that our right is going to point here, and if we find total 2 distinct integers, then we are going to make a count. Okay, and if again I have found 2 distinct integers when my r is at this position, then again I have to add this in my result. When this is going to be my subarray, then again I have to add this in my result. So when my r reaches at this particular end position, then again I have to add one result. But in this case total 3 distinct integers, so we don't need to add. Okay, then again I am going to start with L here and the right here and everything. Okay, again and again I am going to iterate over each point, right? So see the code here. So this with this brute force, okay, we are going to use sliding window only, but we are running the loop 2 times. Okay, see, it is going to run 2 times over each element. Okay, again and again we are initializing the right and left. Okay, so in this way we just passed 41 test cases. Okay, but for the last large test cases the time limit exceeded error is coming, right? So we don't need to solve this problem using this way. Okay, so I'm going to remove this. Okay, we don't need to solve the problem like this. Now let's try to solve it using sliding window technique, but in just O of n time complexity. Okay, so here let's pick an example. So let me pick this first example only, 1 2 1 2 3. Okay, so what I'm going to do here, so this is my array. Okay, 1 2 1 2 and 3. Okay, and here I have to use one map. Okay, this is my map. Here I have to store my keys, and here I have to store the values. Values is going to be representing nothing but the count. Okay, okay, both are going to be of in type. Okay, so this is my array, and this is index 0 1 2 3 4. Okay, so here now let's understand. So I'm going to use sliding window technique. Okay, so initially both my left and right pointer are at this particular position. Okay, and here I have to make use of count. Okay, so here for our problem, this is nothing but key. Okay, this is nothing but value. Okay, so my k value is given as 2. Okay, so I have to form subarrays in which there are total two distinct integers. Okay, so we can't use a normal sliding window technique. Okay, so in normal sliding window technique, what we are using this formula, right minus left plus 1. This is the normal formula that we are using in the previous videos to find the number of subarrays ending at this particular index, right? Okay, ending at this particular index. So let's say this is a one array, so I have to find the subarray. So if I apply this formula, so my left is at this position, right is at this position. Okay, so if I apply this formula, right minus left, so right is at index 1, this is at index 0, so 1 minus 0 plus 1 is nothing but 2, right? So tell me, are there two subarrays in this? Yes, there are two subarrays ending at this right index. What are the two subarrays? One is 1 2 and one is this 2. So two subarrays are there. Okay, so in this particular example, 1 2 1. Okay, so if I apply this formula, right is at index 2, 2 minus left is at index 0, 2 minus 0 plus 1 is going to be nothing but 3. Okay, so are there three subarrays in this particular window? Yes. Okay, so we what are the three subarrays in this particular window which are which are ending at this particular index? So these are three subarrays, 1 2 1. Okay, and 2 1 and 1. These three are the subarrays. Okay, but these subarrays, are they good subarrays? Because we need k is equal to 2. So in this case, yes, it is a good. In this case, this is a good. Okay, because k is 2. But in this case, k is equal to 1, and we don't need that. Okay, we need the subarrays in which there are total k is equal to 2 distinct integers, right? So we can't directly use this formula this time. Okay, so here let's understand what I'm going to do here to solve this problem now. Okay, so there is a little bit change in our sliding window technique. Okay, there is a specific section of this sliding window technique that I'm going to use here. So let's see. So let me erase everything here. Okay, so now initially both my left and right are at this particular position. Okay, so first of all, say, k is equal to 2. Okay, k is equal to 2. So now here in the count, I am going to count all the subarrays in which my k is less than equal to 2. Okay, I am going to count all the subarrays in which my k is less than equal to 2 first. Okay, so here when my both left and right are at this position, then apply the same formula. What is right minus left plus 1? So 1. So I am adding this one subarray here. So my count is 1 plus. Now after that, my right reaches at this particular position. Okay, my right reaches at this particular position. So now right minus left plus 1. How many subarrays? Total 2 subarrays, right? I am applying this formula, right? Right minus left plus 1. So 2 subarrays are possible. Okay, so here I am also storing the value. Okay, this is the first key 1. How many times? 1 time. Now this is subarray LR. Okay, and 2 is the element. 2 is not there in my map. Okay, so 2 Now 2's frequency is 1. Okay, so right now see here, k is equal to 2 right now. Okay, so we can include this one as well. So 2 minus 1 plus 1 is here right now, but is my r. Okay, r is at this particular index 1. Okay, so 1 minus 0 plus 1 is nothing but 2. Okay, so are there any two subarrays at this particular position? 1 to 2. Are there any two subarrays? Yes, there are two subarrays. So I am going to write here 2. Okay, and what are the two subarrays? So this is first step. And what are the two subarrays? 1 and 2 and 2. Okay, I have to find the subarrays which are ending at this r. Okay, which are ending at this index. Okay, now this is done. Now after that, my r reaches at this particular position. Okay, now see, now we are considering this subarray. Okay, so in this subarray, tell me, is there any new integer that we have found? No. Okay, there is no new integer, but a value of this one becomes 2 right now, right? In this particular subarray, right? The value of 1 becomes 2 right now, right? And what is r minus l plus 1? This is going to give me the subarrays which are ending at this particular index r, right? So r is 2 minus 1, 2 minus 0 plus 1, so 3. So 3 is going to be the count, right? Plus 3. Okay, when what are the three subarrays which are ending at this particular r? So three subarrays are 1 2 1 2 1, and just this one. Okay, this one is also one subarray. Okay, ending at this particular index. So these are the three subarrays. Okay, so I hope that this is clear. Okay, so now my r reaches at this particular position. Okay, my r is reaches at this particular position, and again see, we didn't add anything in our map, and our map size is again 2 only. Okay, because there are total 2 elements, so we have to again add this in our count. So r minus l, r is 3 minus 0 plus 1 is 4, right? So I have to add here 4. And what are the 4 subarrays which are ending at this particular r? Okay, so 4 subarrays are 1 2 1 2 2 1 2 1 2 and 2. Okay, these are the 4 subarrays which are ending at this particular r. Now after that, once this is done, my r is going to reach at this particular position. Okay, my r reaches at this particular position. Now this 3 is not in there in my map. Okay, so here 2 becomes 2 also, right? Last time. So now 3 is not in my map, so I have to add this 3 in my map, and 3 frequency is 1. Okay, but see here, if I add this 3 here, now my k is 3. See, in this sub array, my k is 3, right? In this window, my k value is 3, so I don't need to add this in my count. Okay, so what I am going to do at this point, I have to move this l to next position. So now my l reaches at this particular position, so I have to, when my l reaches at this position, so I have to drop this frequency of 1, right? So my new 1 frequency will become 1, right? So here I am writing 1. Okay, again there are total 3 elements in my array, right? In my subarray, 1 2 3 distinct elements, right? So I don't need to consider this frequency in my count. Okay, I don't need to add this in my count. Okay, so now again my left is going to reach at this particular position, and I have to drop the frequency of 2. Okay, so now my 2 frequency will become 1, but still size is 3, right? In this subarray there are total 3 distinct elements, right? So I don't have to include this in my count. So again I have to move my l. Okay, so now my l left reaches at this position. Okay, so now I have to reduce the frequency of this 1. Okay, so now 1 frequency will become 0. Okay, and when my 1 frequency will become 0, so I have to just remove it from my map. Okay, so now there are total two distinct elements in my subarray, right? Two distinct elements in my subarray, right? So I have to include this, right? I have to include this in my count frequency. Okay, so simple formula here: 4 is my right index, 3 is my left index, plus 1, total 2. Okay, 4 minus 3, 1, plus 1, 2 to 2 index, right? So what are the two values that I have to add here? Okay, So 1 is going to be my 2 3, and 1 is going to be just 3 right now, right? So here I have added total 2 right now. Okay, this is done. Now after that my L is going to reach at this next position, and when my L reaches at this particular position, now see, the frequency, this 2 becomes 0, so we have to remove it. And our k our k is less than 3, right? Our k is less than 2, right? So we have to include this 3 in my sub array. Okay, so let's add it here as well. Okay, so I have added this 3 here as well. Okay, so now plus 1. Okay, so I hope that this is clear. Okay, plus 1. Okay, so now what is the total count here? Okay, after that R is going to reach at this position, but we have already covered everything, so our loop will end. Okay, so what is the total count? 2 3 6 10 12 13. 13 is the count. Okay, 13 is the count, right? 2 3 5 6 10 12 13 is the count. Okay, but are these all are good subarrays? All these are not good subarrays, right? So what are the good subarrays here? So this is a good subarray. Okay, let me mark it in red. This is a good subarray. Okay, this is a good subarray. This is a good subarray because k is equal to 2 here, and this is a good subarray. This is a good subarray. This is a good subarray, and this is a good subarray. Okay, is there any other good subarray? Because in all other subarrays k frequency is less than 2, but we need k exactly 2, right? We need k exactly as 2. Okay, but in all other subarrays k frequency is less than 2. Okay, so here this is 1 2 3 4 5 6 7 should be my output, but what I am getting here, I am getting 13. Okay, but I need 7 right now, right? So what I am going to do here, this is the result that we have found for k is less than equal to 2. Now after that I am going to find the result for k less than equal to 1. Okay, k less than equal to 1. Okay, so same way again I am going to start from left here, right here. Okay, and key value everything. Okay, but this time I am only going to add these subarrays, this one subarray, two subarray. Okay, because I'm going to need k is less than equal to 1. Okay, 1 2 1. Okay, this one will come, then this 2 1 2 will come, this 3 will come 2 times. Okay, so this is what I'm going to get when my k is equal to less than equal to 1. Okay, so here I have initially I have found for k is equal to 2, then after that I have to found for k1 by k minus 1. Okay, initially I have found for k, after that I am going to find for k minus 1. Okay, so if I am going to find it like this, so now what is the count that I am going to get next time? 1 2 3 4 5 6. Okay, so what I'm going to do, I'm going to minus this 13 minus with this 6, and this is going to give me my output, that is nothing but 7. Okay, so why this is happening? Okay, why this is happening? Okay, so I hope that you guys are clear. This is what I have found for k is less than equal to 2. So same way, if you guys will find it for k less than equal to 1, then you will find all these subarrays. Okay, all these only, this one, this one, this one, this one, this one, this one, right? For k less than equal to 1. Okay, so these are the things that you are going to find. Okay, so why this is happening, okay, so let's understand this. So we have to find for k is equal to 2. Okay, we have to find for k is equal to 2. So what I am doing, I am finding for k is equal to 1. I am finding for k is equal, let's understand this with this example. I have to find for k for is equal to 3 in my problem statement. Okay, so I am finding everything with k just like this. Okay, k is equal to 3. Okay, and in k is equal to 3 everything is coming, k is equal to 1 is coming, k is equal to 2 is coming, k is equal to 3 is coming. Later on I am saying you guys, let's find for k is equal to 2. Once we find for k is equal to 3, k is less than equal to 3, once we find k less than equal to 3, let's after that find for k less than equal to 2. Then next time you guys only will find like this only, right? This is for k is equal to 1, k is equal to 2, right? If you guys find first for k is less than equal to 3, then you guys will find something like this, just imaginary things. Okay, you guys will find something like this. Then after that I'm going to tell you guys that find for k less than equal to 2. Then you guys are going to find it like this. After that I'm saying that just subtract it, then you will find only this end result now in the end, which is not going to be nothing but k is equal to 3. I hope that you guys are clear now. Okay, so this is what I'm doing here. Okay, here I am getting all the sub arrays in which my k is less than equal to 2. Okay, okay, I hope that you guys are clear with this. K is less than equal to 2. Okay, so now let's write the code. Okay, let's write the code, because I hope that you guys are already clear with what I'm saying here right now. Okay, so now let's write the code. Okay, so code is going to be very simple here for this problem. And first of all I have to subtract. Okay, first I will find for the actual k is equal to 2, and then I have to find for k is equal to 1. Okay, and then I have to subtract. So let's call the function here directly here. I'm going to call one function, return at most distinct, and in this I am going to pass my nums array and k, and as I have told you I have to subtract it with at most distinct nums of k minus 1, because in this way I will find for k only, not at most k. Okay, I will find for k only in this way. Okay, so I hope that you guys are clear. So this is what now let's define this function. Okay, so private int at most k, in this I am passing my nums array int nums and one value of k that I'm going to pass. Okay, int nums int k. Now inside that I have to use my standing window technique. So I am finding first length, n is equal to nums dot length, and my left is equal to 0, my right is equal to 0, count is equal to 0, and result is equal to 0. Okay, okay, so this is done. Then after that create one hash map in which we are going to store the frequencies. Hash map keys of integer type, values of integer type, map new hash map. Okay, this is done. Then I have to run one loop while right is less than n, while my right is less than n, and after that right, while right is less than n, after that right int current value I am picking where my right index at, right, nums of right. Okay, and then map dot put frequency of this current element. Okay, current key map dot get or default. If this key is already there, then pick that value, otherwise pick 0 and add 1 in that. Okay, and if map dot get cur is equal to 1, that simply means that first time I am getting this element in my sub array, then I have to count the frequency. This is count is going to take care of the distinct elements, so I am counting at distinct elements. If map dot get is equal to 1, that means that new distinct element comes into my sub array, so that's make it count plus plus, and then I am incrementing right plus plus. Okay, and while my count greater than k, okay, if it becomes greater than k, then in that case I have to slide my left window right. So int prev is equal to nums of left, pick this left value. Okay, and if I pick that left value, okay, so I have to remove the count of this one. So map dot put prev, I pick this prev, and map dot get what was the previous value of this prev, and in that previous value of this key I have to reduce 1. Okay, because I am removing this element, because my left is moving to the right direction, right, my left is moving forward. Okay, that is why I am using this. Now after that, if a map dot get this priv, okay, if this will become a 0, that simply means that this element is totally removed from my subarray. That simply means that I have to decrement the count of distinct elements in my subarray. Okay, that's what I am decrementing here. Now after that, my left is going to move forward. Okay, plus plus, this is done. And here in the end, this is the formula, normal formula, which is going to count the number of subarrays. So result is equal to result plus, okay, can I write it like this? Result is equal to result plus right minus right minus left. Okay, this is done. And after that, we have to just return the result. Okay, so now let's run the code and see if there are any code issues. Okay, all the test cases has been accepted here. Okay, in the formula I'm saying that right minus left plus 1, so let's use that as well. Okay, why to confuse you guys? So all the test cases has been accepted. Now let's submit it and see. So our solution is accepted right now, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.